Hi, everyone, and welcome to our sparc assemble presentation. The SPARC project provides well-curated datasets for advancing bioelectric medicine. And the SPARC community processes this data in workflows to generate novel results, insights, and knowledge for quantities of interest. These quantities of interest could be membrane potential of a certain cell within the body, or activation patterns in organs. Now, the SPARC measurements could be used to evaluate these quantities of interest together with a number of models and tools that have been developed by both SPARC and the international community. Our vision is to be able to assemble workflows that will allow us to leverage these measurements to help evaluate these quantities of interest. However, a challenge is that the workflows need to be manually defined, and we also need to guess which tools and models might need to be used. So the problem is there's no option for users to easily find and access existing models, tools that can process or interpret SPARC measurements. It's also difficult to easily assemble new workflows to evaluate the quantities of interest, where we can reuse the tools and models that are already available. And it's also difficult to easily identify which SPARC measurements already contain the inputs required for these workflows. Lastly, it's also difficult to identify which measurements, tools, or models might be missing for any given workflow that we assemble. So our solution is SPARC Assemble, a Python tool to automatically assemble models and tools into workflows for processing and interpreting SPARC datasets in accordance with FAIR principles. So what we provide is an easy-to-use API to access existing tools and models from the SPARC repository and also external repositories. We also provide the ability to automatically assemble workflows by providing a quantity of interest. And we can also identify the SPARC datasets that can be used as inputs to these assembled workflows, and also can help identify missing inputs for the models or tools that are used as part of this assembled workflow. We use natural language processing to make it easy to specify your quantity of interest, and we also save the assembled workflow as a SPARC dataset to enable its reuse. We've assembled a number of tutorials as part of this project, and these include annotation of models and tools from existing SPARC datasets, building a knowledge graph for automated workflow assembly, and here we use the add-on ontology. We also show how we can add models and tools from existing SPARC datasets to the knowledge graph, and also how we can add non-SPARC models and tools to the knowledge graph. And here we provide an example of adding models from biomodels repository and also tools from the workflow hub. We also show how we can automate the assembly of these workflows using natural language querying, and this includes listing all possible model and tool combinations, identifying the SPARC datasets that can be used as inputs to this workflow, and also identifying missing model or tool inputs. And lastly, we show how we run the assembled workflow. Now, overall, as we've been developing this project, we've been incorporating best practices for applying FAIR principles within this Python module that we've created. So overall, the impact, SPARC Assemble will help support SPARC DRC and community developments by fundamentally transforming how we search for resources. And we can further enhance the capability of SPARC Assemble by integrating with existing SPARC knowledge bases, such as the functional connectivity maps and the anatomical connectivity maps. And lastly, we can also help the SPARC community by using SPARC Assemble to link to external measurements, tools, and models, while also letting the community run their workflows on other platforms, for example, using Spark Flow. So our team would like to thank the Spark program and the Spark Codeathon members for allowing us to participate in this Codeathon. Thank you very much.